Hello everybody, today we're gonna make swirly scratches, similar to the ones we can see on cars, hoods and all these kinds of coated surfaces. We're gonna see what they are, how they're done, and I'm going to give you more than 50 scratch maps and a tool I created to generate your own.
Look like nothing's gonna change.
So today we're going to make these kind of swirl scratches. They exist in all shapes and sizes. I've done a few renders with some of the maps I'm going to give you. Really, they have all kinds of different looks. The general effect is that your reflection is going to show around the reflection in a swirl. These kind of swirls are mainly visible on car hoods, and depending on the settings you choose, you really understand why some people call them spiderweb reflections. This kind of reflection is so pretty and so elegant and can really elevate some of your surfacing work in very specific cases in close-up work. Let's start by looking at some references. What are swirly scratches? So swirly scratches are fairly common. As I was saying, they're mainly present on car hoods because essentially they're just dents and scratches inside the surface of the coating. They have absolutely nothing special physically speaking. They're really just long carved streaks inside the coating or any other surface for that matter. But in this case, why are they swirly? Well, they're not. Let me explain. So, clean reflections are very easy to apprehend. The light ray reflecting from the surface either reaches your eyes or not. But when you introduce disruption in the surface, if I activate the bump here, you start having light rays that you weren't supposed to see suddenly hit just the right peak at just the right angle for it to reflect and reach your eye. When you start having this kind of behavior on the surface, you can think of reflections as probabilities. And regardless of the shape of the light, the probability of receiving a rogue light ray is much higher around the edges than it is further away, for example. And that's why the reflection with bumps still respects the original shape of the light. So if we keep on this probability analogy, if we increase the disruption, well, in this case, the probability of having just the right pick with just the right angle to send new light rays into our eye becomes much higher at a much further distance, and that's what we interpret as blurrier. But what I really want to highlight here is that despite the reflection being blurrier, it's still just that, the reflection. It doesn't suddenly change shapes, it still preserves the original reflection shape. Well, it's the exact same thing for swirly scratches. They're not swirly at all, they're really just bumps that increase the chances of light rays coming into our eyes at a further distance. The only reason we see them as swirly is because the light we cast on them usually appear round or squarish, and when you blow square, it looks round. But for example here, it's still very much respecting the original reflection shape, which is a star. So how do we remake them? Well, the unsung hero of Look Dev, Anisotropy. Anisotropy is sort of a cheat, similar to roughness. It fakes roughness that has a structural consistency, like thin long peaks and long valleys. I'll make a video explaining it eventually, but for now just understand that for anisotropy to work, it needs a quantity and a direction, and this is kind of really specific data that prevents us from using random maps we find online. So I have a perfectly reflective shader here to display a little bit of what anisotropy is. What I can do is start introducing some disruption, and it's going to blur the reflections, and anisotropy is basically just that, except because the disruption has some sort of consistency in direction, it gives the illusion that the reflection is stretched across the surface, but it isn't. And as I increase the strength of the disruption, it's going to stretch the reflection even more. Now, one thing that's important to notice is that despite my disruption going from left to right and being horizontal, you can see that the reflection is stretched vertically, so the direction of the stretch is perpendicular to the direction of the disruption. And when you use the example of the cylinder, you can really understand why anisotropy looks like it's stretching reflections. While it's not actually stretching the reflection, you can see that it's actually duplicating the reflection across every single angle variation on the surface. And so because the reflection is repeated again and again and again, it looks like it's stretched, but really it's just repeating the same reflection as long as it can catch its light. So why not use bump then? Bump in real life, bump in 3D, right? Well, not exactly. While approaching this with bump is commendable, this effect really benefits from anisotropy in all aspects. To have successful scratches through bump, you'll likely need multiple scratch depths inside a mix shader, which is considerably slower both to render, manage and retake. Despite my anisotropy renders using mixes, outputs and maps with fully disabled MIP mapping, it still renders twice faster than V1 bump that has no mix shader to match the richness and the depth of the anisotropic shader. Since you don't have an anisotropy amount equivalent, you get insanely intense scratch reflections that get full white and well above 1 very easily, requiring extra reflect remap that slows render down, as opposed to reducing anisotropy, which makes the render faster. Bump and high values aren't really friendly, and if you want some intense scratches, you get a lot more flickering. And lastly, you lose control in customization, as you're unable to bias direction through outputs to get branching effects. Instead, you need to use custom bump maps and make your own. But luckily, the map and the tool I'm giving you can also be used for the bump approach if you prefer that way. So let's create it. And this is the shader that we're gonna create today. The structure of the shader is very simple. I'm going to use one of my scratch maps for the demo, but you would be free to use any scratch map that you find online with the required data. Because the scratch map uses 4-channel, RGB and alpha, the first thing that happens here is that I extract each of these channels into their own outputs. Red is random 1 and I use it for the roughness. Blue is random 2 and I use it for the scratch's anisotropy amount. And lastly, green is anisotropy direction. Each of them go through their own little process and they ultimately get fed inside the shader. The shader itself is really simple. For this example, I've just set up a simple metal, but you're free to use this technique on any shader you'd like. And we're going to start by recreating this scratch pattern. So the first thing you want to do is grab a Vray material. You're going to apply it and we already name our work. I'm going to make it a metal and I'm going to keep it quite bright to see the reflections. Now the first thing I'm going to do is grab a Vray beat map and I'm going to import one of my maps. For this example, I'm going to use natural, 72 directions and maximum density. Because we're going to use actual numerical values and not color values, we want to make sure that we read the map as a data map and not a color map, so you want to set it up as either none or invert gamma. Same thing here, this is going to be a data map and not a color map, so we're going to set up the RGB primaries to raw. And just for convenience, I'm just going to duplicate this texture and extract the alpha manually. To do this, I'm just going to scroll down and in RGB output, I'm going to set alpha as gray, alpha output is going to be intensity, and mono output is going to be alpha. This way I make sure that in every single channel the alpha is extracted, and just to make sure both share the same coordinates, I'm going to drag and drop the first texture inside the second. So the first step is going to bring an RGB tint to extract each of the channel of the texture we choose. So I'm going to plug it in, and I'm going to extract my red value by making red white, and making green and blue black. Name it R, duplicate it twice, G, B, set green to white, red to black, and in the third one set blue to white and red to black. So now that the texture is plugged in, we can take a look at how it looks like in render. So as you can see, the texture is pretty colorful, but we start understanding what's going on if we just select one of the 3 channels here. If we just select red, we can see completely arbitrary values. As I was saying, red is random 1. Similarly, if we take a look at blue, we have just as arbitrary values because it's our random 2. And last but not least, if we look at green, we're gonna start seeing some consistency. As you can see in green, every single vertical line has a specific color, every single horizontal line as well. Basically, for this type of map to work, you need the orientation of each line to determine its green value. So what we're gonna do for the roughness is simple, we're just going to plug in an input. I'm going to set up the roughness as 0 to 0.1. And now we have some scratches. Now the thing is, not every scratch map is going to have a full alpha like here. Some scratch map may have, for example, very few scratches. In these cases, you might want to choose the physical properties of the scratches themselves and separate them from the properties of the rest of the material. So what we're going to do before starting to work is we're going to plug in a mix, set this to color 2 to show up in our black values, and we're going to plug our alpha into the mix amount. So now we have the actual scratch roughness, and we have a mix so we can plug a second texture that will be the rest of our material. As always, we rename each of our nodes to be clear, and we're good to go. Similarly, I'm going to do the same treatment for blue, and I'm also going to plug a mix here. This is going to be our anisotropy, and I'm going to plug it in the corresponding slot. Before touching the anisotropy for clarity, I'm going to set up the green channel. And the green channel is not going to need any mix, because we're basically going to nullify it inside the anisotropy slot, so the direction is not going to show up in these spots. Right, so now we have a working shader. So the first thing we can do is start tiling the texture a little bit more to see a little bit more scratches. But everything has disappeared. Why is that? Well, the scratches start to be so thin, the blur amount is starting to hide them. Vray's blur is basically MIP mapping, so depending on the distance from the camera and the size of what you're trying to see, it might hide some detail, so make sure to turn it off. What we can do is start introducing some anisotropy here, and just make sure to never go above 0.95, but in this case just know that 1 is completely invisible and rolls back to 0. So for now I'm going to set it up to 0.8 and a minimum of 0.5. Now I just realized I forgot to relink the dense texture, so I'm going to do just that. And now we can start seeing some stuff happening. So the thing you're gonna see here is that the scratches are not in the right direction at all. And the reason for that is that the direction is literally aligned with the current lines. And as we saw, anisotropy is an illusion that stretches the reflection at a 90-degree angle. So in the case of anisotropic direction, 0 and 1 are gradients from 0 to 360 degrees. So 0 and 1 will have the same direction, but also 0.5 because 180 degrees is essentially just the opposite. So we need to shift the green value by 0.25 to shift the reflections by 90 degrees. And there we go, our effect is achieved. That's really just how the shadow works. Now you can start playing with the roughness if you like, and the other physical properties as well. You can increase the size of the circle with the roughness, and you can increase the preservation of the reflection with the anisotropy. And there we go, we have a finished shader. Now the shader will work with any texture I've uploaded, but feel free to tweak it to your liking. You can even make your own textures, or if you find some online, use them as well. The principle is always the same regardless. As long as you have a texture that has direction linked to intensity, you can use it. Now there is a specificity that I would like to discuss. You might find that some of the edges might be a little bit too crunchy. Now if you're using a texture that doesn't have full alpha and shows some of the original material underneath, you might want to clarify the separation between the scratches and the rest of the material. To do that, you can just go inside your mix node. And what we're gonna do is that we're gonna use the mixing curve tool. If you're not using Vray, you can just use a new output node. And we're going to use it to add contrast onto a map, and in this case we're going to force the color 1 onto color 2. So to do that, we're going to reduce the upper influence, which is color 2, and we're going to increase the lower influence, which is color 1. And now you can see that we have more color 1 presence, and it still respects the alpha, it's just making sure that there's less transition. Similarly, we can do the same for anisotropy, and so we're just going to force color 1 onto color 2. And now the distinction between the two materials is a lot sharper. Now there is a neat trick that I would like to show you. If you wanted to create some branching without using the limited direction maps, what you can do is that you can plug the anisotropy shader into a new mix node. And what we're gonna do is that we're going to remove anisotropy based on direction. So we're going to replace the anisotropy slot here, and we're going to reroute our direction map into a new output. We're going to plug the output into mix amount, and we're going to set color 2 to black. Now we're going to invert our map, and what we're essentially going to do is that we're going to make everything white. And we're going to draw some shapes that go down to 0. And what it's going to do is that it's going to ban some of the anisotropy based on direction. And now we can see that we have some completely arbitrary branching. Another cool trick I would like to show you is how you can create this kind of rainbow colored scratches. It won't really work on metal, it's more of a coating thing. What you're essentially doing is that you're adding a thin film layer on top of it all. So what you're going to do is that you're going to go inside your shader, you're going to enable thin film, and you're going to reduce the IRR just a little bit. You want to make sure that the minimum thickness is at 0 nanometers, so that anytime black is plugged in, there is absolutely no thin film visible. So what we're going to do is that we're going to extract one of our two random masks. I'm going to take red for this time. As I've just said, if we're playing in black, there's going to be no thin film at all. And we're going to reroute this output into its own output. This one is going to be thin film thickness, and the other one is going to be thin film IOR. Now I just plug the maps accordingly, thickness into thickness, and IOR into IOR. Now the IOR is obviously wrong, because an index of refraction of 0 looks like an index of refraction of 100, so we need to put 1, 1. 1 is going to be our minimum quantity, basically none, and because we're using a random map, only some of the scratches will have a thin film. So we're going to set it up to maybe 1.1 here, just to have a very subtle thin film layer. Now we can see there are some artifacts here, and they would be way less visible if we were using this as a clear coat layer. And there we go, now it's just much more discreet. By the way, if you wanted to add more direction, what you can simply do is that you can overlap two different textures. To do this, you can rotate the texture. Because of that, there will be a mismatch between the direction mask and the line directions, so you need to manually offset the green channel. Now we can plug in a mix, add a new texture, use Sim Alpha, and we're going to send it into our masks. Similarly, I'm going to update the alpha channel. So alpha 1 into color 1, alpha 2 into color 2 using the alpha 2. Now you can see that the direction I chose are probably wrong. I'm only going to offset by 95 degrees. And now we have our rainbow colored swirly scratches. Obviously, just for the sake of the tutorial, I've used a map that's very intense and very visible. In real life, swirly scratches tend to be fewer, so make sure to add them tastefully and not have too much. If you wanted to play with the color, it's very easy. All you have to do is play with the thickness curve. And if you thought there was too much, it's also very easy. All you have to do is bring every value down and make them closer to an index of refraction of 1. Now, I'd like to talk a little bit about the limitation of this technique. So I've got a card set up here that I'm going to use for this demonstration, and as you can see I have some pretty intense scratches for the demonstration. Now if I come closer to the card, we can see I have some pretty nice swirly scratches all around, and you can see that I have the same shader everywhere. By the way, for this example, I'm using natural 400 densities 72 directions with an anisotropy from 0.85 to 0.9 and a roughness from 0 to 0.05. This way I have an extremely large circle with extremely intense scratches, but that aren't very wide. Now you could think everything is going well. We have our scratches, we have a little bit of an anisotropic line here, but the main limitation of anisotropy is that it is UV direction dependent. What this means is that the effect you're going to have is going to change depending on the angle of view based on the direction of the UV island. On this car roof, the UV island is oriented vertically towards my camera, and we can see that our scratches are behaving properly, but the issue is going to start appearing if we look at the Anisotropic Scratches at an angle that's mismatching the UV island orientation. Now you can see that the effect is completely broken. We're back at the step 1 where we had to create an offset on the direction map to compensate for it, and this is completely normal. This limitation comes from having to specify the direction for every single bit of anisotropy on our model inside the shader. But luckily, we do have a solution. If you come into the shader, you may have noticed that under the Anisotropy shader, you have local axis controls. These axes give additional information to the Anisotropy shader and specifies the global axis it should be working inside. When you have z-axis selected, your anisotropy is optimized for an horizontal viewing. Everything will work fine if you move left to right, but will start breaking if you move up and down. And since the car roof is oriented upward, we start living the context of our z-axis. To fix the shader, we just have to switch to another axis. In this case it's gonna be y, and now the shader works for every object that is oriented upward. Personally, I think this limitation is only a little cost to all the benefits that come with using the anisotropy for this kind of effect. If you wanted to plan every single situation, you would just have to create 3 shaders and give each of them a specific local axis, and you would just plug them into your mod sub object and select all the problematic objects to give them a new material. Considering this technique is really oriented towards very close-up work, it's a very little price to pay for much faster render time, cleaner renders, and more flexibility with the effect. And there's been some recreations online, but they're all private, so I pulled out my socks and I did it myself. And this is why I created my own scratch map generator, and I'm giving it away for free. You can find it in the description. The generator is After Effects based, but because not everyone has After Effects, and also it takes quite a while to tweak and export the maps, I've also exported more than 50 maps for you to use straight out of the box. These maps come in 5 different styles. Each style has different subdivision of direction, you know, the possible direction on the reflections, because sometimes you might want to have less or more depending on the stylized look you want. Sometimes a surface is really just exposed to a few directions of distress. They will have this kind of limited directionality in the swirly scratches, and each direction comes in different densities of scratches, sometimes 3, sometimes 4. So yeah, I'm hoping these will be useful to you. You can find them inside the description and let me know what you think. I don't think my tool is perfect, and I'd love to make a V2 someday. Probably Substance Designer based this time. So the way the After Effects tool works is pretty simple. As a user, you just see the final result of the settings you've chosen. And the cool thing with this is that you can just come into the first composition and draw your own shapes. For example, if I want some swirl scratches that have some roundness to them. I can also disable the displacement if I want something that's a little bit smoother. And now if I come back to my first composition, now it's here. So the tool is pretty slow, I recommend setting it to half. What the tool allows you is to increase or decrease the density. You can also select the possible directions in here. You can increase the rotation between each scratches within a direction. Scratches will have a unique variation within one direction. You can change the X and Y scale of each scratch, and you can increase the randomness in length between each of them. For example, if I increase the random length to 150, now some scratches are completely compressed. So if I increase the density and switch to a different channel, we can understand what's really going on. For example here, if I just extract the green channel in all channel and bring an extract, we can see what's going on. The basis for this workflow is that anisotropic direction goes from 0 to 360 degrees, but we can plug a map in it that goes from 0 to 1. So each of these values from 0 to 1 corresponds to an angle, and we use this to specify the angle of each scratch through their value. If you find that your map is not seamless enough, you can come into the other option and increase the random position. And lastly, if you don't want any alpha and have as many scratches as you can just increase the density with the super density control. So, we've seen what is anisotropy, what are swirly scratches, how to replicate them, the limitations and the benefits, and how to create your own maps. I hope you find all of this video instructive and clear. Let me know in the comments if you have any thoughts or question. Make sure to grab the textures inside the description and have fun yourself. And on this note, I will see you next time.
Sitting here resting my bones in this long